Hello. Give me a minute. We're still pumping down the SEM. So just need to get the chamber completely evacuated before we can start passing electrons through it. So we're almost there. It's getting ready to flip over to green, and I'm going to turn on the thingy and then the thingy. You know, the thingies. The accelerating voltage now on. And then there's a little bit of calibrating that needs to be done. Normally, I try to do this before I start. Today, I went to lunch, so there's a little catch-up needs to be made. But I had a good lunch, so there's that. Let's see what we got. If anything. Well, it's out of focus still. Time zone greetings. Is that how we manage morning, afternoon, evening now? Just time zone greeting? Greetings from a time zone. Well, we're at a height. I'm gonna do the scary part and move the stage up now. I'm gonna do that again, get us a little closer. All right. Put my headphones back on. I like to be able to hear the motors when I'm doing that, because it is actually literally the only part of using the SEM that's potentially going to damage the instrument. And so I'd like to be able to hear what's going on, basically. And then it makes me a little bit more comfortable about making adjustments to the height. So, not sure what we'll get. I looked at these samples in the light microscope just briefly, and I saw what looked to be Stephanodiscus like diatoms. Could have been Cyclostephanos. A centric diatom, which they're round, not unlike the one that I have on the microscope right now. It looks like this could be one of them. We're a little dark. I can't really see much, so I need to make some adjustments still. Oh, also the beam intensity is very low, because I think I was taking a high resolution photo when I stopped. I'm gonna fix that. And it's not really helping getting anything better into clear focus, so I'm not sure that that's a diatom. It is something round, which is usually a good sign, but there's no detail, which is usually not a good sign. We can come back to it. Scale looks okay in terms of size, but not sure what's going on with it. So these are sort of interesting samples. the hey Samshung and Estrella, hello. These samples were collected from sloths. So I mentioned when Pacific Plankton was here that one of my sort of fever dream wishes was to try to look at diatoms that had been collected from sloths. And as a Christmas gift, basically, she decided to try to see if she could make that happen. So she knew somebody who is a friend of ours, Steve Mandel, who sometimes shows up in the streams. And he knew some people that work with sloths. And so he talked to them to see if they could send us some materials, and they did. And here we are, looking at sloth diatoms, possibly. These ones were collected by running a toothbrush through the fur of the sloth, and also I think on the feet, around the feet of the sloth, like on their toenails. And so I'm really not sure what I'm looking at right here, because this doesn't seem like it's a diatom, but it's very round. So still working that out. So to collect these, I actually took the toothbrush and I cut the bristles off of it. Yeah, I'm really not sure what that thing is. It's like the other thing, some little round object, which does not seem like it's a diatom, like that one up there. But the toothbrush, in order to get all the diatoms off of it, I just cut off the bristles, and because it was very low concentration. And then I put the bristles into a beaker with some acid, basically, to digest the diatom part. And I'm hoping that's what we have here, is some diatoms from that. There's some other things that may be present on here, and then I asked Mallory to make me some pretty high concentration versions of these samples. So let's try, while we're just sort of tinkering around. None of these samples will have very many diatoms in them. They'll be relatively uncommon. Because the toothbrush samples, when I looked at them in the light microscope, they had maybe 10 or 15 diatoms total on them, so not very many. And there was a bunch of sort of clays and other particles, some sort of debris. So that's probably what this junk is. And then the toothbrush bristles also kind of made a mess of things. So that added to the challenge a bit. And I managed to get most of the toothbrush bristles extracted from it. And then what was left over is hopefully still got some diatoms in it. So hopefully it doesn't have any toothbrush bristles still in it. But it's got a bunch of, I think that's probably pollen. We had it sitting in hydrogen peroxide because I didn't think there was a lot of stuff present, and it was only in it for about I think it was overnight, basically, so not as long as I might normally leave something to digest, because I just didn't think there was a whole lot of organic matter present for me to worry about. So let's try and do some adjustments to the gun. and see if that gets us a little bit darker. Looks yummy, like sugar crystals. I'm not sure that's what that is. Um, Surprised there aren't any mushroom diatoms on these sloths. I didn't get to actually brush the sloths. Um, I only got the toothbrushes. So I was, at some point, I think it's been offered that I will be able to, if I go, because these are from outside of the US, if I get a chance to go there, at least Steve thinks I might be able to visit the facilities and then potentially collect some of the sloths samples myself. But I'm not sure when that will happen. So that's still a ways into the future potentially. Right now we're not super keen on traveling anywhere, but the person who runs or manages the facility, who's friends with Steve, has offered to collect more samples. So if for some reason we don't end up with a lot of diatoms in these samples, there's still a pretty good probability that we get some later on. And they seem to think that there would be more diatoms during the wet season. These were collected during the dry season. So still don't know what these things are. This is the third one of these little weird ovals that we've seen. I don't think that's a diatom, but I don't know what it is. So they keep tricking me into thinking they might be a diatom, and then when I zoom in on them, they are some other little structure. I might image one of these eventually. My guess is it could be something like grass pollen or some sort of a pollen, but not knowing the composition of it, it's kind of hard to tell. A lot of times the sort of debris, the fur and stuff that might collect in dust particles, basically. And I'm guessing that's how the diatom particles are also getting into these sloths, is that they are being blown onto them rather than something that's growing on them. But I can't say that for sure. So this is obviously a diatom. Stephanodiscus, I think. This is the mantophotoportula around the outside margins, and that is the rimiportula. So this is definitely, unquestionably, a diatom. It's slightly dissolved, and so I'm gonna guess it's a Stephanodiscus. That's the shape of a Stephanodiscus. They're round with radiant areolae that are grouped into things called fascicles, or little bundles, basically. And at the end of each of these little rows, there should be a mantophotoportula, and that's what we have. And the surface goes like 1, 2 to 3 across to 4 across, and then you're at the edge of the diatom. So this is the valve face, and this is the mantle that's on the outside that's sort of pointed up towards us. So this is pretty cool. When I looked in the diatoms that I saw in the light microscope for these samples, it had something in there that I thought was Stephanodiscus or possibly Cyclostephanos, but I didn't recognize it, which would be normal because these aren't from a place where I usually work. So it wasn't like I looked at it and was like, oh, I know this species. But I knew that it was a Stephanodiscus or Cyclostephanos. So this one is very small, and some of the other ones I saw were actually kind of large. So it may be a different species. Just working on getting the focus a little bit tighter. So my guess is that these diatoms aren't ones that strictly live on sloths, but are maybe just ones that are being found on the sloths. And the reason I say that is so they're probably just blown onto them, or potentially they're in a local water source that's nearby. It doesn't have to be a very big one. It could just be like a little pond, or even just sort of like something that they use to get water from, if it's open, and diatoms might collect in it. And the reason I say that is that this is a usually what I would consider to be a planktonic diatom, one that lives in water, and it's also a little dissolved. So normally, if this were a pristine living diatom, these openings that you see here on the surface would have a covering over them, a little like salt and pepper shaker covering over them. And instead what we're seeing is a bunch of little, if you look very carefully at those edges, or if I zoom in on them, you'll see that these little holes are actually open. And what you're seeing is like there was a cover there, but it's been broken or dissolved off. So you can see that here. The sort of structure of it's missing. But along the margins, you can see these little poker chip structures. Those are actually where that salt and pepper shaker would have been basically attached to that opening, covering, as a covering. So sloths are slow-moving organisms, and they live mostly in trees, but they can, in their fur, can grow kind of robust communities of algae. And I've known that diatoms could grow in sloths. People often sort of remark that there's sort of these algal, I don't know if you call them mats or whatever, growths that happen on the sloths over time, especially in like humid conditions, because they don't move a lot, and their fur sort of makes a good habitat for algae to grow in. I was always a little surprised that diatoms were part of that community, because I usually think of them as being water organisms, but they really need to be in any kind of sort of subaqueous environment will be okay for them. So, but this I think is probably not something that was living. It's probably just something that was captured in the sloth's fur. But it's still the first diatoms I've ever seen in SEM from a sloth. So I'm pretty excited about it. In Exit U, hello. Yeah, so we're today looking at one of my Christmas presents, which is given to me basically through favors by Steve Mandel and Pacific Plankton, two friends of the channel. And hopefully Pacific will be able to join us at least for a little bit today, so she can kind of see some of them, but if not, I'm sure I'll post them to my Discord and she'll be able to see them there. So this is kind of a cool first diatom that I've observed from an SEM from a sloth. So let's see. We've got the settings are more or less how I like them. I'm going to take that picture. Just get a little 3-minute image. And yeah, it's kind of a long, drawn-out Christmas present, but this is just part of it. So we'll get some samples from the sloth people, and then we'll get some more samples from the sloth people in the future, which are also part of this Christmas present. And Steve has also sent me some additional samples. Diatoms ought to be posing for camera. They are, in this case, sort of. So we have some diatoms from sloths. That's one of the gifts. And with pouts and duck lips. Well, we've got lips. Up here we've got the Rimiportula lip structure. It's not quite a duck lip though, but I get what you're saying now. Um, so we have these ones, and then Steve is also sending me some samples from an Ecuadorian cloud forest, which I'm super excited about. And I heard from my wife that those arrived in the mail today at our home. So those will go into processing probably for a week or two from now. And then the other big part of this gift is hippopotamus samples, which Steve is working on getting for me as well. The diatoms living on hippopotami. So, and I cannot explain to you how excited I am to look at diatoms that may be living on hippopotami. So, it's in the works, but it's part of my Christmas present. So it's a pretty good Christmas present. Um, and they haven't arrived yet, but I'm hopeful that sometime this year we'll get the hippopotamus diatoms, and we'll probably get another batch of at least one more batch of the sloth diatoms. So super cool. They just look like normal diatoms, of course, because they're diatoms, but they're interesting because of where they're found. So, as I mentioned, this is some sort of Stephanodiscus. I don't recognize it. That's not surprising because it's not from the U.S. And I've never done any work in the country these originated from. So, it's likely there's diatoms I haven't seen. So, but I can get it into the genus pretty easily. I'm pretty sure that that's a Stephanodiscus. So, we're very closely related to it. Give me a second to do a little bit of finesse on my labeling system. This is Del 2. Alright, let's see what else we can find. This is a little one. And even though I picked it out pretty easily from what we had, I suspect there's probably more in here. And I'm going to see where are we? Because they're so sparse, or potentially so sparse in these samples, it'll be a little bit of hunting, basically, to try to find things. And I took 3 samples, I think. I think we have 3 or 4 samples from these on the SEM today. That is a girdle band of an SEM, of a diatom. That is not Stephanodiscus. It looks like maybe it belongs to Echinanthidium or something like that. But it's just the girdle. So as always, the SEM is sort of a hunt. Looking for things because they're tiny and in this case easily lost in a matrix of things, probably like sloth dander or something like that. But I keep running into these little oval shaped things which I'm pretty sure are not diatoms. I'm going to have to get an image of one of them, but I'd really like to see an internal view, and I think we just keep getting external views. So it's sort of a cup-shaped object. Like, could be anything. guess it could still be a diatom. I'm just not convinced. An internal view or looking at the inside of the cup would really, like, you know, if I could see the other side of it, it'd be more convincing. There's another one. This is just a piece of clay or silt. Could be a diatom. It looks like there's two pieces. And some of these look like little portals. But it doesn't look like there's like a open frame of holes. At least not very large ones, if there are. So I'm going to keep looking and maybe we'll find something like this where it's an internal view. The elliptical shape of it's a little weird. Like it's part of the reason I'm not super convinced. Diatoms that are oval like that, you know, Cockneese maybe. But it could be that we're looking at a something completely unknown. I don't know how many diatoms have actually been looked at from sloths on an SEM before. So I don't want to say that it's definitely not a diatom yet. Just it wasn't convincing to me. So there's another, whatever that thing is, there's another one. Certainly doesn't seem very convincing as a diatom. Because these were collected on a toothbrush, it's possible it could be some sort of microplastic particle. I don't know for sure. Just kind of a question mark what it could be. So when there's really, really low concentrations of diatoms, it's one of the sort of problematic things about that is that contamination is potentially a more serious issue. Usually in lake sediments, there's so many diatoms that contamination is not something that I usually worry about very much, because I've made samples with just like water and I didn't get any diatoms at all in them. Pretty regularly somebody screws something up and doesn't put the sample on correctly, and then there's just a sample with water. There's never any diatoms in it, or not in a concentration that's high enough for anybody to observe them anyway. All of those little elliptical things that we've found have been face up. Which means it's impossible for me to tell what it is, at the moment anyway. I'll stop on the next one that we run into, regardless of which way it's facing, and then get a picture of it. There's a diatom. Right there. That is not plankton. That is a navicula. That is a internal view of a navicula for sure. And I need to change the beam intensity because it's a small one, so I can optimize the focus. again, it's pretty degraded. It's broken, and it looks like it's slightly dissolved. Again, I think it's probably just something that was probably blowing around in the dust, not something that was living on the sloth. And the reason I say that in part is because I used a pretty gentle approach in removing the bristles. I just cut them off and then into a beaker, straight into the acid, or oxidizer in this case. And so that doesn't seem like a process that would like smash diatoms. And this one's got a fracture in it right here. So let's rotate it around. That's maybe 35 degrees. And slightly too far. And then I can zoom in just a little bit closer for the photo. It's not going to be the greatest photo ever, but I kind of want to have it at least in focus. Good enough. And then I can come back and check out in the chat. This looks like it's sort of coated with a little bit of junk. Could be some of the material from the sloth. It could be something that, it just got damaged and picked up on the way. If it was blown or scraped onto the sloth somehow. Give that a chance to develop, and then I can come back in and see what's going on here. Hey, duck, goose. How you doing? Doesn't the USA have a list of exceptionally learned minds to summon during a crisis? Or is that just in movies? I think it's just in movies for the most part. Recent UK news, giant ancient millipede found in giant sea creature fossil. Sounds cool. I think octopus live on Earth. I think they're actually from Earth, but I could be wrong about that, Griffin. Caleb. Dead Sea diatoms. I'd like to see some diatoms from the Dead Sea. That'd be okay. Makes you really sad when you get a water-only sample, yeah. Yeah. You gotta give them some pretty good directions. I don't know if whips are a good idea if you want them to keep collecting stuff for you. Hello, Dr. Derp. How you been? Let's see. Did I forget to send out? I did. I need to send a shout out to Chippy Flippy. Chippy. Thank you for hanging out with us here, Chippy. And I've got like a derp command in here and a studio command in here. I got some streamers, you guys. What? There it is. Some streamers and people generating content that you should definitely check out. Dr. Derp will, when he streams, it's usually just, he streams as a 3D printer that talks occasionally. So that's cool. And a Flippy Chip streams from a spaceship pointed at the stars. So if you like night sky stuff, it's really boring, don't bother. I mean, if you like watching paint dry, it's at least twice as exciting as that. So watching something grow over time is kind of neat. Like long-term builds. It's just that it takes like, I think one of them was like 30 hours to build, and then he was like, yeah, it messed up, I gotta do it again. So um, it's not captivating, but it can be interesting to check in on it periodically and see what's going on. So, especially when the 3D printer talks at you, I think it works out pretty well. It's a navicula. I know this is a navicula, by the way. It has a raphe. It's cracked along the raphe right here, actually. And then it has these striae. That's the collection of areoli on the valve face that are in rows. These ones have sort of a costi-like structure between them because the areoli are thin and they're lineolate. In other words, sort of look like little tiny slots that are parallel to the raphe, like mostly parallel to the raphe. So you can see those here, 1, 2, 3. They look like little dashed circles. There's like 5 of them in a row right there to make up the striae. Usually we can describe diatoms by the nature or the orientation of the striae, especially that's common for navicula. So this navicula has curved radiate striae in the center. They become mostly parallel here and slightly convergent towards the end. In other words, they point towards the apex if you go from the outside to the inside. And the ones that are here that are radiant, if you go from the outside to the inside, point towards the middle of the diatom, right? So they're pointed in opposite directions, and the only way for that to happen is to have some in the middle that are pointed neither direction, right? And then it's a pretty small diatom, so that's the internal view. Still something we can easily pick out as a diatom. I didn't see any of these in my light microscope images, by the way, when I was looking around. I didn't see any naviculas. I did see some diatoms, but maybe they were in the other sample. I have 2 samples, and these are actually a little bit higher concentration than the ones that I actually made for the light microscope. So yeah, that one's another external view. Starting to think they're all external views. Now I need to straighten this out before we get too far off track. And I can go back and look at the other, I have the other sample on here, 2 other samples on here from the sloth as well. So I suspect we may have some more diatoms to look at on those. Something over here. All debris, no diatom. So a clear indication that you're looking at a diatom. It will have typically some very distinct geometric shape, like defined outline, with a clear, often with a very clear set of holes that cover some part of it, and usually 2 valves are present. Here's one, here's the other. Sorry, this is one valve out here pointed out towards the top of the screen, and then this is a girdle band. So the diatom's valve face is over here, and it's over brightened, so we can't really see very clearly what it is, but that is a diatom for sure. I need to fix the brightness settings a little bit and see if we can get the valve face to show up in here. Just guessing based on the shape, maybe it's an amphora and we're looking at the back side of it, but I'm not positive about that. Again, there's all kinds of possibilities when we are looking at something that I don't really have any idea because I've never seen it before. job interview. Good luck, studio. Um, Hopefully it works out. Looking forward to you having a job again. Maybe you're not, but probably appreciate having a salary again. Let's see what we got. It's almost to the point where I could see the diatoms, so it's just like, be patient. It's definitely a diatom, and I'm pretty sure that that is an amphora. It looks like maybe these are the areolae, which are like slits, like long slits. So like in the amphora pediculus or inariensis sort of group. But I can't see enough of it to actually tell what's going on. So not the best picture of a diatom, but that's definitely a diatom. There's two valves, and there's a set of holes up here that we can't see the valve face, but we can tell that it has a set of holes. And it looks like the other valve is missing, because here's the girdle bands overlapping onto nothing. So there should be another edge to this amphora that looks basically like this one that would be on this side. It could also be that it's pushed into the valve, like it got squeezed into the valve, and we're just seeing a bit of the girdle bands overlapping it. That happens sometimes. Conveniently, it's basically at the right angle for me to just go ahead and take a picture. So even though it's not the most exciting diatom, I haven't seen any amphoras, so we'll just go ahead and take that picture. I want to double check my focus up here where this areolae are. Something like this. And my beam intensity is too high. Good enough for a side view. While we were getting started, I got followed by somebody called Ofjun. Ofjun, thank you for the follow. We have broken the 2,500 followers plane. We've always been just sort of sitting a little below it for the last couple of months. So that's nice. Also, I've added some new emotes for people who are subscribers, and also just follower emotes. So I have this little guy, that's a new one for the follower emotes. You can see them pop up on the screen when you use them. And these new heart emotes, which are all on here now as well. There we go. Those are hearts with diatom textures inside of them. So, sort of fun. So now you can tell people how much you love diatoms just by click of the button. There you go. I love diatoms. So I feel like this thing always gets stuck in the front of everything, and it should be in the back of almost everything. Good. So this is pretty cool. 3 different diatoms, none of which I had observed in the light microscope. These might have been from the feet samples. One of the issues that I got was I just got some toothbrushes in 2 different bags, and they weren't labeled like where they were taken or anything. Just like sample 1 and sample 2. So no idea which one was which. I thought maybe it would be clear when I looked at them which one came from the feet versus which ones came from the fur, but you never know. Also on the slides today, or the stubs today that I have, because I told you I only have 3, but if you look in the little picture window over here next to me, you'll see there's actually 7 stubs on there, are some other random samples that I'm working on, getting some images from. These ones are also pretty interesting. They are collected from, they're anthropologic samples. They were collected from human teeth, remains of humans and their teeth, and the calculus, like the plaque that grows and develops over your teeth, can trap things from what you eat in it. And diatoms will sometimes get trapped in the teeth of things, like humans. Previously, we looked at some dental calculus that had been collected from chimpanzees, and we did a stream like that, like, I don't know, last year sometime, and that was pretty cool. These samples are also pretty cool. They're from the teeth of humans. There's no actual remains of humans, obviously, but their teeth have a little bit of calculus, a little bit of a buildup of plaque, basically, that hardens. And that material, as I said, can trap diatoms. And so somebody collected that and digested it, not like in their stomach, but like with chemicals, and then sent me some of it. And then we're working on a paper, and they think it's a big deal, some sort of anthropology thing, about food sources or something like that. I'm really on the project just to identify some of the diatoms, and I told them if they sent me some samples, I would put them on the SEM. So I have some of those samples on here as well that I need to image some of the diatoms from so that we can use them in publication. So sort of a working stream with a little bit of fun mixed in. I don't know what this thing is. I'm fairly convinced it's not a diatom, but hello, Two Chooks. How are you doing? Hopefully you're having a good new year. I think this is the first time I've seen you since the new year, but if not, you can still get wished Happy New Year, I figure, all the way, at least halfway through January. So, still safe to wish people Happy New Year. It gets a little awkward if you start saying it, I feel like, much later than that. Because, the year's already a 12th of the way over after January. So, how are you doing? I sent a little message to Little Chook, telling her Happy New Year, because I haven't seen her streaming for so long, and it seems like she used to be on all the time, and I think maybe once she got a job, she just didn't have time to stream anymore. So, consequence of having a real job and being like an adult. I mean, I have a real job, but this is sort of my job, so. Also, I have a potential special guest coming to visit the SEM lab a little bit later. My former master's student, Sabrina Brown, who's now Dr. Brown, who teaches at Defiance College, is here to visit. And she's been working on some stuff in the lab and collecting some samples from when she was here to take back with her. And I think today's the last day she's going to be around. She's been here all week and going home tomorrow or something like that. So I think she might drop by if she's getting ready to leave. She might just pop in and say hi. So don't be surprised if that happens. Hey, the little thing in the window right now is this diatom. Right there. It's Discostella astericostata. Alright. I don't know what this thing is. I'm just going to label it thingy. Elliptical thingy. That's a science name, right? Elliptical thingy. Sciencey enough. And maybe I'll be able to figure it out later with some Googling or, I don't know, phone a friend. Or we'll see an internal view and I'll decide that it's definitely a diatom. Could happen. I did see a cracked one, a couple of them that were cracked. Could also just be some sort of a pollen spore. I do have friends that work on pollen who would be able to tell me for sure. I might need to ask one of them. There's a broken one. Yeah, it's definitely not a diatom. See, the internal and external views, it's basically solid. Not sure what it is, but I know what it isn't. Mystery particle. To be determined eventually, hopefully. But I think an internal view like this will be helpful. So it's basically shaped like an M&M. Sloth candy. It's best I can do. It looks a little bit like a cracked egg, yeah, I agree. If eggs were very narrow. Because I think it's like, not only is it elliptical this way, but I think also in the per-valvar axis, I think it's also elliptical, not round like an egg. It looks more like a pita to me than an egg. Like a pocket pita. Just stuff something delicious inside of there. Or like the outside shell of an M&M. No chocolate in it. Pretty small one though. And also elliptical. Mysteries are fun though. There's a lot of mystery in our sample today. Definitely not a diatom though. There's no girdle bands around the margins. There's no obvious holes on the valve face, or on the surface of it rather. And it looks like it's kind of solid, like a shell. Candy shell. let's keep our search going for diatoms. There's a very little round thing here. I'm not sure what that is. Not a diatom. Could be a bit of debris. Looks pretty rounded though. It's another one of these little candies. This is a diatom though, I think. Yeah. That's a diatom for sure. Kind of looks pretty abused. That is a valve face photoportula. Those are mantle photoportula, so definitely a diatom. It has areolae on the valve face and a valve face photoportula, but I don't see a rimoportula, which means it's probably on the margin somewhere. Maybe this thing. It looks probably like a little tiny cyclotella. That's what I'm gonna guess right now. So small as to be uninteresting to me in a way. Again, probably not living on the sloth, just sort of found on it. That's a diatom. That's a stephanodiscus. This is the external view of the diatom we saw before. The little steph that we saw when we first started. That is definitely the same diatom. It's little. There's the spines going around the outside margin. It's a steph for sure. Good enough for us to just snap a quick photo of. Octams. Yeah, diatoms are a type of algae. Tiny microscopic algae. Not visible, typically. Or if you had a whole bunch of them, you could see them. That's the same stuff diatomaceous earth is made out of. That's just like billions of diatoms in that material. If you get enough of them, you can actually see them. And the algae make a skeleton. So different from most algae, they have a rigid silica skeleton. Most algae have soft skeletons or no skeleton, no cell wall that's like non-organic, right? Just organic cell walls. So diatoms have their cell wall is basically made out of silica. And they are single-celled organisms, so generally pretty small, the size of dust. Yes, so the images below me in the slideshow are from this SEM that I collected here, and then I colorized them using whatever nefarious techniques I use to colorize things, like Photoshop and Procreate and Lightroom, Adobe Lightroom. So mostly these images, when I have really cool SEM images, I will colorize them and then add them to this slideshow. And I post them all also on Instagram. So there's an Instagram account for the SEM lab here, which is the first one, and the bottom one is just my photography Instagram for me. Not filled with diatom images, but macro photography and birds and stars and whatever else I take pictures of. But the have I ever done a stream of colorizing some of the SEMs? I have, Chippy Flip. In December, I think I did a stream where I just showed everybody the different techniques that I use for colorizing and gave some examples. Um, but it was a here are the techniques that I use sort of stream, and not like a work stream where I was actually colorizing something to keep it. So I was just showing different things you could do. Um, Occasionally, I think, oh, I should spend some time doing a stream where I just colorize stuff for people as part of the stream. But um, it's usually done like when I need a break from work, and I don't always necessarily want to stream at that point. I just kind of want to have a little creative time of my own. So I tend to not do those as like real streams. Corkbird, thank you for the subscription, Corkbird. 3 months in a row. Well, 3 months anyway. Thank you for that. Uh, for to continue answering your question there, Chippy Flip, it should be still in my video list if you wanted to watch an old one. But I'll try to do one where I'm just kind of like colorizing stuff. I just feel like, I don't know. I don't necessarily think it's exciting for people to watch because it's a lot of me just changing my mind. Like, don't like the way that turned out. But I mean, I guess that's a lot of streaming for art. Um, but it's easier than it looks, I will say that. And I just taught myself how to do all of it, so um, I don't have any art training. I mean, I know how to use photography tools like Photoshop and Lightroom because I taught myself photography. But for colorizing photos, I don't use any of the skills that I use for those, except for trying to get things to not have so much noise or whatever. So I'll try to do one. If I think people are really interested in it, if people seem like they really are interested in it, I'll definitely do it. It's easy for me to do, and I actually have a bunch of I have a bunch of work I need to get done for it. I owe one of my collaborators some colorized work. There's like a list on my computer at home that of all the materials that I agreed I would probably try to do some colorizing for in sometime last year, and I did a bunch of other things for them, so they're not really like complaining about it, but I feel like kind of need to get on it here sooner or later. Okay, well, we've gone through one half of one of these stubs, and I just want to go look at the other stub because I definitely saw different diatoms in the sample and in the light microscope than what are in these. And so I think maybe the other sample might be a little bit better. I don't know. We'll see. Yeah, there's already a bunch of diatoms. That's in Ensynema. There's another one. These are probably, again, just things that got carried into the sample. That's what I was seeing in the light microscope, was this guy. This is another Steph. I don't know. It looks like there's several of them. My guesses at first is I thought maybe they were just contamination. And they could still be contamination. That's a concern. If there was some dust on the material. These are Stephanodiscus for sure. And that is a Lindavia. It's another one of these stuffs. It's a concern, because that could just be some contamination from my lab. These are diatoms that aren't completely different from ones that we see. This is kind of like Stephanodiscus caruscus. And these other ones also occur in the June Lake samples. So if that's the case, maybe we don't have sloth diatoms? Hard to say. It would be the first time we really had a significant amount of contamination, though. And I work with stuff all the time that's like a wide range of, like, in time that would be very distinct. Like if we saw Afrosimbella in here, I'd know that it got some contamination for sure. That looks like an Africa or a. They look like Stephanodiscus caruscus to me, which is problematic. I don't know that we ran anything in these samples, in these containers, though, that would have had these diatoms in them. A question. What was that noise I heard, though? A new follow from Octans. Okay, thank you. I know I've told you before, but whenever I'm watching you and my wife looks over my shoulder, she says, wow. Well, that's cool. Say hello to your wife for me. It's nice to hear. We might need to... Hey, Tropical Geek. How you doing? We need to move over to some of these other samples and see what else we have. Before it gets too late. I started about like an hour ago already. Is that true? What's my uptime? Yeah. Alright. Well, I need to jump over to these human teeth samples. Hopefully there's no contamination in them. And see what we find. That's a diatom right there. So these were collected. That's a Nitzia. That's actually the one that I, something similar to the one that I saw in this sample from the light microscope as well. I thought I saw something that looked like it might be Nitzia or Hantzia. And I think that's a Hantzia, but without the whole diatom, it's kind of hard to tell. So for these diatoms that have a keel raphe, the raphe's on the margin out here on one side, and then they have these connecting pieces, struts or structures called fibulae, and then these little holes are areolae which line up to make striae, and so they have this really characteristic behavior where the fibula come down onto the valve face. They join a costi between two striae, and that's where they stop, basically, right here at the valve margin. And then the raphe's out here on the back side of this field of view. For the other diatom valve, like we're in the inside of the diatom right now. If we had another valve, it would be basically facing us, flipped over, so that the inside of the diatom would be not visible, if that were the case. And so this is what we would call an internal view. And I'm just going to click that picture, even though it's just an okay one, because it's kind of a broken diatom. It's just a fragment of one. But it's enough that I can tell what it is. Teeth samples, yeah. These samples were collected by some anthropologists or archaeologists. I think they're anthropologists from the teeth of hominid skeletons. I don't know the ages. I think they're maybe 3,000 or 4,000-year-old teeth that they collected them from the skulls of. And then they just sent me the materials. So I know you're asking yourself, did I get to take diatoms out of the teeth of the skeletons? But I did not. Another missed opportunity. I believe they were collected in northern Africa, but like on the boundary between the Middle East and Africa in this sort of Levant province. And they collected the material that got stuck in the teeth because they're kind of curious if they could figure out what people had been eating. And they wanted to use a series of different tools, the diatoms being one part of it. Actually, they didn't really want to use the diatoms. They wanted to use phytoliths, which are more commonly picked out of dental calculus between teeth. And they sent it to some guy who looks at the phytoliths, and he found some diatoms, and then he sent them to me. So like I'm just sort of adjacent to the project, which is why I don't have a lot of the details. But then they asked me, like, why would these diatoms in particular that we found be in the teeth? And I'm like, I don't know. Like, I'm not an anthropologist. I study diatoms, but they got very excited when I gave them some possible explanations, and then they told me that they wanted to put a publication together. So I needed some images of the diatoms that we'd observed in the light microscope for the SEM, so that we can work on putting them into the publication. So they're including me as an author, even though I hardly did anything besides identify some diatoms. So I thought maybe it would be a good idea if I actually did a bit of real work, and then could share this with them, and then they would be like, there's a real reason to have you involved on the project other than just you identified some diatoms. So this is from 59. Power. Yeah, I think it's a Hansia, the genus Hansia. Hansia are literally found in everywhere, in places like mud puddles and soil samples. They're one of probably the most common diatoms on Earth in a way, because they're found in soil. So every time it rains, they get a bit of water, and they crawl into mud puddles and that sort of thing. And then they're very active for a little bit in the mud puddles until they dry up, and then basically they're part of the soil again for a little while. So they're really interesting, what we call edaphic diatoms, which means they live in soils, and their presence in anything archaeological would not surprise me. And a lot of times people send me samples where they just want to know, like, where'd this thing come from? Or they see some diatoms in the light microscope, and then they ask me, like, what's this diatom? What's it mean? And I'd say, like, if it's an anthropologic sample, 8 times out of 10, it's probably Hansia. It's just something that was living in the soil that got collected with the material. And it may not have even been, something that was stuck in the teeth at that point, because if the sample was collected from something that had been buried, right, there's a possibility that some of that stuff just got trapped on the surface of the teeth, post-depositionally, after the organism died. So I don't usually have a whole lot of, like, here's what this means for those. And these are usually like things that are found in soils. So they could be contamination, or they could be, people get dust on themselves, or they get dust in materials that they're using. So it's totally possible that it's just a bit of dust that got blown onto the material, onto the sample. Even if it's in place, it's a little bit challenging to say anything about it. Some dust fragments and some organic matter. These samples I don't think we did anything with. They may have not been treated or anything, because they were just a bit of scrapings from the teeth. I think they had to work really hard to get them shipped to me, because they weren't allowed to leave the country or something, but they managed to process them, and then it was allowed to leave the country. What was that? Corkboard. Oh, thank you for giving out a subscription to Chippy Flip. Now Chippy Flip's got all these diatoms he can use. It's got all the diatom emotes. And when you're in Hannah's stream and she's singing about diatoms, you can attack with the diatoms. Chippy Flip. It should be a pretty neat paper. The people who are involved with it, the anthropologists, are doing most of the backbreaking work, because I'm just the guy who identified some diatoms and told them what I think they meant. And this sample is actually there was a sample where I saw some Hansia, and I wanted to get some pictures of that for them. And there wasn't a whole lot else in this sample, but the next one that we go to, which is in this set, is also from the same material, is there's two samples that are right next to each other. I don't know where they were collected or when they were collected or anything, but they are 85 and 86 are the next two that we'll look at, and they were actually filled with diatoms. Like, I was confused what I was looking at, because normally there's very few diatoms in samples from teeth or of any type of dental calculus, but these actually had a lot, and so I'm kind of excited to jump over to them, and especially if this one's just going to have Hansia in it. I don't think that we'll learn a lot from that. Just wanted to sort of poke around at it and see if there was anything else that was a diatom in here that that we could easily identify and get maybe a better picture of a Hansia than we have for the light microscope. So, but I don't even see that. Just a few dried up blotches of stuff without many diatoms in it. So this is what I normally see in a sample of this caliber. Let's do a contrasting sample and look at one of these 85 and 86 samples. Hopefully they've got the same kinds of diatom composition that the ones in the light microscope had. This is 85. You can see diatoms all over the place in here. So these are Olicosyra, all of these. Here, Olicosyras. And that is a Lindavia in the sort of Radiosa group. And here's some more Olicosyra. They are all over the place. All these little squared cylinder sort of things you see That's a Lindavia or a Cyclotella. But all of these things that look like little crowns, um, those are all Alicosiras. Every one of them. With these little Cheerio holes in them, also Alicosiras. And, this is really surprising to me when I looked at them in the light microscope. I was like, all of that stuff is all diatoms. So some, that's an abundant number of diatoms for being picked out of a human's teeth. Um, an unusually high number of diatoms are present. And this diatom, I'm not so sure what it is. I know it's an Oligocera. It kind of looks like it belongs with the distans group. But these pictures will be super helpful for us trying to figure that out. You see, they've got these really long spines that come out from the valve face. These ones are broken off, but they have really long spines that come about halfway across the valve. So that'll be useful for us to try to figure out the species. And like I said, I think these are like 3,000 or 4,000 year old, maybe older. Diatoms, so they're fossils collected from these materials. I should really do a little bit of reading they're putting a paper together, but they haven't yet shown me the whole paper, so I've just inserted my part as an email, and then they haven't really shown me the rest of it, so I don't know what the rest of the paper is necessarily going to be composed as, but I'm okay with that. A lot of times in science I just have to do my little part, so you've seen papers. Yeah, people get papers for less. It's Ash. What's up, Ashley? How are you doing? I think if you type, is it Ashley, or maybe it's just Shmoo? I think maybe it's just Shmoo. We get the Shmoo that shows up when you type the Shmoo. There it is. Shmooing. How you doing, Ashley? Just hanging out with us here in the diatom world for a bit. My Shmoo is better than Hannah's Shmoo. What can I say? I worked hard to make that Shmoo show up for you. And my Shmoo also shows up before. I actually had that done before Hannah did. So just throwing that out there, Hannah, if you're listening. I got your friend's emote up, and I don't even know what she looks like, and we're not friends. I mean, we're like Twitch friends, but, I got it up before you did, though. Are there methods for discerning the age of the diatoms so that you can date them relative to the teeth? Not really, but there is ways of dating the teeth and the material that's around the teeth, if there's organic material. The diatom skeletons are made out of silica, opaline silica, so there's nothing in them to date. There's no carbon. It's just SiO2, basically, with some water mixed in. And the organic matter that's present probably isn't from living diatoms anymore, so it's hard to put an age on any of that stuff. But the materials that they were trapped in, either the skeletons of the humans, those will have some carbon probably associated with them, or the material that's around it, like if they have wood that they were buried with, or fragments of wood that are in the sediments that are where they were buried, or leaves or things like that. Any kind of carbon, basically. That will have a date. And my guess is they know how old these are. They probably have a pretty good age model for it. I don't know what it is because, like I said, I'm just helicoptered in on a project, and I identify some things, and then, I do what they want me to do. If they have some more important task they want me to work on, then I'll do it. But in this case, they just asked me to identify diatoms, so I did. So this is 85, I believe. Sample 85. I think the other one also is full of diatoms, 86. So this is Olacosyra, and it's a small chain. One of the things that's sort of interesting about these samples to me, there's a lot that's going on here. One is that there's all these diatoms present, right? Not totally clear at this speed, but all of these little round things, here, those are all Olacosyra. All of these things, and all of these little guys over here, they all are chain-forming diatoms. They live in colonies together in the plankton. And it's weird that they would show up in the, the calculus of a human's teeth in this number, right? That's a lot. So, I'm curious how that happens. And they were really curious once I started explaining these are plankton. And also this thing up here, this Lindavia, and there's also the other sample I think has some Stephanodiscus in it. I think that's a Lindavia down there as well. They all are plankton. Everything plankton. So that's like a deep water diatoms. And so they're trying to figure out, like, how do you get that stuck in your teeth? And one of the suggestions that we had was that they were eating shrimp, and that the shrimp were basically filter feeding the diatoms. And so they got some of that stuck in their teeth. One suggestion is maybe they were eating fish, and the fish are deep water, they feed on deep water stuff, and the people eat the fish, and then it gets stuck in their teeth. Another suggestion is maybe they were being buried in sediments from the lake. That's a possibility. So then they started asking me, do I know where the diatoms came from? And I'm like, I don't even know what country they were collected from, so no. But they asked me, do I know, like, would I be able to tell if these were the same diatoms? Because the people that were living here were living right on the edge of a lake. And they said, could you tell whether they were living and eating from stuff out of the lake, or whether they were coming from the ocean? And this, I was like, definitely I could tell you that, because I work in freshwater diatoms. Occasionally I look at marine diatoms, and they don't look anything like each other. So that's easy. And these are freshwater diatoms. So do present pescatarian cultures, that's like fish-eating cultures, exhibit the same distribution of diatoms in their teeth goop? I don't know. That's a question I wasn't really, like, prepared to answer, because they're the anthropologists. I'm just the diatom guy, and they didn't even know what a diatom was at the start of this. I had to kind of explain to them, like, the phytolith guy knew what the diatoms were, but he can't interpret them. And they were like, whoa, you can tell all this stuff from these little things? And I was like, yeah. So I don't know that people have looked at the diatom in modern cultures. You need a dentist, yeah. I don't know that many dentists keep the stuff they scrape out of your teeth, though. Like the tartar, I think maybe that doesn't get kept, usually. And maybe the way that they ate the food was a little bit different. Like today, we're really finicky about taking out the little, like, intestinal vein in shrimp and deveining them, which is really just their intestines. Throwing away cold, yeah. Something to start saving for posterity. Yes, we're going to scrape this little bit out of these people's teeth, and then we'll just keep it in my scrapbook. This is this patient. Here's what they've been eating, and here's what their teeth junk looks like. Maybe. I don't know, but this is an overview. There's a lot of diatoms in this person's teeth. Whoever sample number 85 was, this is a lot. Uh, um, they really like to eat the diatoms. And as I mentioned before, when people ask me what do diatoms taste like, I say Smarties. Because I don't have a good idea of what they taste like. They're too small to taste. Um, you know, probably if you got a lot of them together, they wouldn't taste very good. But um, you're not tasting the diatoms probably at this point. You're probably just tasting whatever they were in. This is this really large thing, super weird diatom. Some sort of Stephanodiscus, I guess. I'm not positive. And then this is that Olicosyra again with the long needle-like teeth. A very Islandic kind of a look, I think, is what this one is. You see these really long spines, and the spines from this one go into the grooves on the other one, and they come about halfway across the valve of their sister. So this one's got spines that come halfway over this one, like overlapping fingers, basically. They're holding hands through the centuries, and millennia in this case, right? Of holding hands with their sisters. And they're all over like that. Ooh, an epithemia. This is like Epithemia sorex down here. Better get an image of that. This is not plankton, by the way. This diatom, some sort of epithemia, lives on things like lily pads and macrophytes, basically. Plants that live in the water usually have these on them, on the leaves. And they live in conditions where there's limited nitrogen often because they have a endosymbiotic relationship with nitrogen-fixing cyanobacteria. And what that means is they have captured cyanobacteria and they use them to create nitrogen for them. Like they're little prisoners, basically. And these diatoms specialize in housing them while they're alive and using them to farm nitrogen for them. So in environments where nitrogen is very poor, these diatoms will live where other things don't do so well. Kind of cool. Detector Menke asks, do you have photos of mites? Yes, I have like hundreds of photos of soil mites, if that's what you're interested in. Some of them are on my Instagram page. None of these mites were collected from people's teeth, thankfully, but we definitely have a collection of mite images, and that is because one of the professors that's here in our department looks at soils. In particular, they look for mites that live in soils, and so like, can't see it, but there's a poster over there on the wall just covered with like mite photos from the SEM. They look at like the types of mites that are growing in the community garden that's here on campus, and they've collected some material from farm soils, and they have some mites that they collected from well, thank you for the follow. They have some mites that have been collected from people's yards and stuff as well. And they try to do some comparison for like soil health. At the end of last semester, I had a grad student that's working with one of these guys here. Basically twice a week he was using the SEM to try to image some mites to try to see how well they would tell about soil health. And he had collected some from areas that had been mined, where they were close to mining operations, and then the land had been reclaimed. So they had some that was like in pristine environments, some where there'd been mining operations that occurred, and some where the mining operations had reclaimed areas they had mined. And he was looking to see if the mites were different from one site to the next. And then this other guy, Jim Spear, who does the soils for the community gardens. He's on sabbatical this year, so he probably hasn't generated any new stuff, but um, for a whole year he was in here basically all the time on the microscope looking at soil mites and trying to use the SEM to help him identify them. Most soil mites you can identify without the use of an SEM. You can usually just use a nice stereo microscope. You don't need super high resolution to image them to get what you need. Oh, anonymous cheer. Thank you for the bits. Um, every little bit helps, I guess. This is 85 still. An epithemia internal view. So yeah, he has a whole bunch of a giant library of those images, and if you go to my Instagram page for the lab, I've colorized some of the mite photos. Um, you know, they're creepy, and sometimes people like the creepy stuff, um, and I don't find them that bad actually, but there's a lot of them. We have a lot of those images. I didn't put a lot of them on the SCM on the Instagram page, but I could pretty easily. Is that a new follower? Thank you for the follow, Chembucha. This is Lindavia. I can't see it very clearly. It's got some junk all over the surface, but that is a Lindavia. It looks like it belongs with the radiosa one that we saw earlier. That's the external view. It's not a great one. And then this is an internal view of Stephanodiscus, I think. It may be a Cyclostephanos. I'm not positive. I can't see all the way to the edges on any of these views. I'm trying to find a better image of one. And then there's this Allocacyras all over the place. One of these samples was like filled with Stephanodiscus, and one of them filled with Lindavia. All of them had Allocacyra of these two, both of these two rather. And then you can see we occasionally come across some other things. But I was trying to find some of these as a better view than the ones that we had. That's Allocacyra again. Sort of Icelandic style with the long spines, or the Subarctica type with the long spines. I don't remember which one it is. I don't have that one very frequently, but it's one of those two. And then these bigger round disc-shaped ones are the ones I want to get a nice picture of, because we've already got a nice picture of some of the Allocacyra. So I'm hoping there's even more on the next... Ooh, there's some. Here's some right here. Nope, that's Allocacyra. And that's an internal view of something. It's the Lindavia. These little windows have costi in them. It's got junk on it anyway, but you can at least tell that it's a Lindavia. And I want to see what this one is too while we're up here. It's another Lindavia. So I'm hoping the other sample actually has more of this large Stephanodiscus-like diatoms, because I really need to get some good images of those. These Lindavia are kind of boring because they're covered. The pores are all covered with stuff, so they're all a little dissolved, which make them slightly less interesting to me. But not horrible, just not great for something to image. I'd really like to get one where I could clearly see the structures. So we'll poke around on this. We'll either come back to it if the other one doesn't have any, and see if we can find some. we'll poke around a little bit maybe after the stream. So I'm going to jump over to the other sample and see what it has. This should be 86. And it's a little bit more clumpy. Maybe it also isn't going to be great. Let's have some things on it here. Those are Alicocera. See the long little spines right here? Sticking up? It's the same species as the other one has. And there's some spines here sticking up. Again, very clumpy. Good junk on it. And there's clumps of stuff in here as well. There's a nice valve face view of one of the Olicoceras. So the spines in this one are basically pointed straight at us, right? Here's the little spines. Each one of these are pointed straight at us, and those are the things that are sort of interfingered together with the sibling valves in the other field of views that we were looking at, where they're on their side. So that's the valve face view. It's round. And normally Oligocera are found like this on their side view or girdle view, like this one. See, they're interlinking. These have a single row, which it ends in a spine, and then the other valve, a single row that ends in a spine, and just back and forth, basically, with a spine for each row. It's amazing, isn't it? This was all collected from some person's teeth. Again, filled with weird things. But especially a lot of diatoms present. A lot of those Oligocera are present. This is a lot of the same stuff. Not quite as dense. So we may want to go back to that other slide before we completely abandon our chance of finding some Stephanodiscus. So I saw some over there, they just weren't great. But they're better than what we have here. There's a big clump of Oligocera right here. See all of them together, all little crown shapes, and then they have like a hollow center when the valve face is broken off of them. Not sure what that is. Thought I saw a phytolith over here. Oh, that's an Oligocera. Still kind of a lot of diatoms for being picked out of teeth, to be honest. Some Oligoceras in here as well. There's one. See the little Cheerios sort of shape? They're kind of hollow in the center like that. Alright, well, we've seen what's here. It's mostly Oligocera. Occasionally some other random things are sort of smushed in, it looks like. Oligocera. Let's jump over to this one other one, and then we'll come back to number 4, which is 85. This one also had some sort of cyclotella-like things in them. that's Oligocera. Same Oligocera we've been seeing. It's present in this sample as well. That's a sponge spicule, I think, right there. That's an Oligocera. It's a little out of focus, but I can fix that part. Yeah, there's two Oligoceras that are, joined together. It's got some sort of a coating over them. Maybe plaque. I mean, it seems most likely given where they were collected. Same species. So one of the things that's kind of neat about this samples is I don't know if they were all collected from the same organism, person. There's a cyclotelloid. But if they all have the same diatoms, that's kind of neat, that they would all have the same diatoms stuck in their teeth. Unless it was just collected from the same person with different teeth. The spaces between different parts of their teeth or whatever. Because it suggests that, as I said, they're all having the same source. And I think I was starting to tell this story, but they're sending me some material from the lake that's near these sites. And they went back through the time frame when the people lived there, and they dated the core at that interval where they thought people were living, and they're sending me material from that interval. So I can look at the lake sample and compare it to what we found in their teeth samples. And that's another way that we could potentially see if this is the potential source for, at the time that they were living, for these diatoms in their teeth. So kind of a neat approach. It should be a pretty interesting paper if that works out to be true. And that was my suggestion to them when they started talking to me. It was like, well, they were like, well, how do we tell if these came from the lake? And I was like, I need to see what's in the lake. I need to see the lake samples. So hopefully they'll provide those. I think they shipped them at the start of Christmas break or something. And they just haven't arrived yet because they've got to make it through customs. And they said, oh, we have a whole bunch of material from it, so if the first batch doesn't make it through customs, we'll just send you another one. Which is terrifying to me as a scientist, to potentially have some of my material get lost because somebody in customs doesn't want to pass some lake sediment through. All right. Let's go back to the easy searching, which was on 4, and see if we can find some good Stephanodiscus images to collect. Because there's this one, but it's kind of dark. And maybe some of these in here. I'd like to get a nice external view. That's an internal view of the cyclotelloid. Lindavia or something. These are all Oligoceras otherwise. All around Oligoceras. So, on a more personal note, it's Sabrina. Hello.
Hello.
Do you want to be on Twitch with me?
I can.
We're looking at some diatoms that were collected from people teeth. And look at how many diatoms are actually in this person's teeth. Look at all those Oligocera.
Yeah, they didn't brush their teeth very well.
I mean, or people use diatoms as toothpaste. Maybe they brush their teeth too much.
Mm-hmm.
Are you headed home?
Yeah.
Okay. You're leaving tomorrow morning?
I'm gonna go to my parents tonight, so.
Okay. Like right from here?
Yeah.
Okay.
So, see you next time.
Okay. What do you want to do about the camera?
Oh,
Because it's at my house.
next time.
Okay.
It's fine.
Okay.
Guess that'll just be an excuse to
Come visit.
come visit sooner rather than later.
Perfect.
Okay.
Sooner rather than later is best.
Yeah.
All right. See you. If you had been around at the very beginning of my Twitch streaming, like a year and a half ago, we did like an interview with Sabrina, and I think a second interview with Sabrina as well. Maybe we need to have her on again. So she's a former student of mine who was here as an undergrad, and then came back after her undergrad to do her master's in my lab. And then she did her PhD with my PhD advisor. And now she's has a job. So she's off doing her own thing. Okay, we're gonna collect this image of the internal view of the sky. Thanks for dropping in and for sharing subs, by the way, Corkboard. It's always great to see you, and very generous of you to donate the subscriptions to people. And hello, Shadowfax. How are you doing? Hopefully well. How small are these things? At the bottom of the screen, it tells you the field of view. Down here, these total field of view is about 30 microns. So there are 1,000 micrometers in a millimeter. So if 30 of these are present, it's a very, very small fraction of a millimeter. They are extremely small, dust-sized particles. Easy to imagine that you could have hundreds of them trapped in your teeth, or thousands of them trapped in your teeth, and not know. So, yeah, and there's a scale bar down there as well that says 5 microns. So the field of view one is probably super helpful, though. It actually gives you the frame. So you're learning things on Twitch. That's what we're here for. We're part of the Knowledge Fellowship, TKF. That's them. They're very supportive of us, especially when we first started. And if you want to hop on their Discord, there's a whole bunch of science content streamers on there. Some of my favorite and closest Twitch friends are also part of the Knowledge Fellowship. So some of our favorite people to hang out with on Twitch in my off times, including people like Science Streams and Encephalosaurus, who's on right now, and Dr. WD40 sometimes hops in here to visit with us, and Paleontologizing, all some of our closest Twitch friends. Pacific Plankton, who's usually here to hang out. Well, just at Healthy Gamers. I don't know them. Or do they do like food stuff? Like exercise or nutrition? What do they do for health? What do I have in my teeth? Oh, a psychiatrist. Oh, that's cool. What do you have? I don't know what you have in your teeth, Chambucha. My guess is you've been drinking kombucha. So some of that. If you brush your teeth with some of that natural toothpaste, like Tom's natural toothpaste, there's probably diatoms trapped in your gums somewhere. I wouldn't put it past it. I would think that that's highly likely. This is a cycloteloid. Can't say much more than that from the field of view. It's internal. All right, let's see. whole bunch more Algacyra, and then there's this thing. This is another one of these cyclotelloids. This one is probably the Lindavia. There's the Rimoportula, and it's on the valve face, so very likely this is Lindavia. I don't know which species, and I would actually argue that it doesn't look like a species that I've seen before, so there's a very high probability that this is an undescribed species. We have this happen a lot. If this is your first time viewing my channel, diatoms are very small, and part of my job is describing new species, and I would say at least, I don't know, once a month or something, we come across some diatoms that probably haven't been described, and they're probably being viewed for the first time ever here on Twitch. I wouldn't put it past this one. This is a pretty weird looking diatom. It's a Lindavia. Its labiate process is way out here on the margin. You can see inside the alveolar chamber there's a costi, a sort of smaller costi than these big ones that go that create the chamber itself. And I really am struggling to find the photoportula. I'm sure they're there, but it looks like maybe they're right here. Can't tell if they're 2 or 3. And then it has these tiny little areoli on the valve face, but I can't tell if that's just because it's covered with some clay or not. But they look like radial, so this is kind of in the Bedanocoid type of Lindavia. This might be a valve face photoportula that's underneath some clay, but we're going to give this one a picture. We'll take it. At some point, you may, I may post a link to some new publication, and then you'll see some pictures that we collected right here on Twitch on that publication. I think the people who originally started this project think it's going to be a Nature paper or a science paper, so if that happens, if it actually goes into one of those journals, that'll be a big deal, because I don't think I've gotten any papers that are actually in Nature or Science. I've got things that are in the next tier down quite frequently, but just diatoms by themselves aren't super appealing as a topic for a lot of people, and it needs a little bit more excitement for them. So we'll see. Science, yeah. Wolfram, yeah. Do I have this in your teeth somewhere? I don't know. Your teeth are likely a post-apocalyptic hellscape. Well, I recommend not brushing your teeth with bleach, Octams. I think that's a bad idea. You could just use a water pick. One of those things that when you have braces, they give you they recommend that you use instead of flossing. Those things will power most of the stuff out from between your teeth. Even the diatoms, probably. If they had those in the old days, it probably wouldn't be able to find any dental calculus. Is there an intro to diatoms somewhere? Yeah. You can get a link there on diatoms.org. It's a highly recommended place to start for looking at diatoms if you're interested. They're a microscopic algae, single-celled organisms. They make a silica cell wall, and there's potentially millions of species of diatoms, but only about, I don't know, something like 30,000 or 20,000 have been described. So there's a lot of undescribed species. And I try to just point out features to people so they can get familiar with the terminology. So if you feel like I've lost you somehow or I'm talking over your head, feel free to ask questions. I don't mind. That's what I do here. Also, there's a lot of time in between when the pictures are collecting that I just kind of like to chat with the chat. It's fine. how do these form? How do diatoms form? They're an algae, and they replicate through what we call binary fission. That's a fancy way of saying they just split in half. They create a new valve inside their existing skeleton. So like this one is sort of cup-shaped or petri dish shaped, and they form another one like this on the inside of that structure. They widen themselves out. They form another one inside, and then this one also forms another one on the inside of it. And then the two valves basically split apart, and then you get two where you used to have one. So yeah, these ones probably weren't living in the people's teeth. They probably died in there, or potentially they contaminated the site of their skeletons, because these were collected from dead people, from people that had been long dead by thousands or at least thousands of years. And the calculus is like the plaque basically that builds up in your, or the tartar that builds up in your mouth, and that actually can trap stuff. So if you go to the dentist once a year or twice a year or whatever you go to the dentist, they scrape your teeth. They're scraping the stuff out of your teeth that this gets trapped in. But in the old days, they didn't have dentists that scraped junk out of their teeth. So that tartar just built up into this stuff they call dental calculus. It's like a hardened plaque. And it stays on the teeth, and it's surrounded by, the plaque itself sort of protects what's there. And then the archaeologists that found, or anthropologists that found the skeletons, took the dental tools and scraped the teeth so they could get this material out from between it. And so it probably wasn't living there. It probably isn't something that that they had on, growing in their mouth, because these are plankton. This is found in lakes, and they might have recovered it from the teeth, but it was probably just like dust that got trapped there. Or, one of the suggestions that I gave to them as a possibility is that they were eating something like fish or organisms that consume diatoms, and they are the base of the food web in aquatic systems. So they're algae. That means that like fish eat them, snails eat them, shrimp eat them, and so if they ate those things, people eat fish, people eat shrimp, people eat snails. There's a possibility that they got some of these, trapped in their teeth. Pretty good possibility, actually. A probability, really. A high probability. Or they could have just been blown in as dust and get trapped on your teeth. Your teeth probably, in between trips to the dentist, probably have dust that gets trapped on them, and then gets locked into that dental calculus. So it's kind of a weird topic, like here's what's stuck in my teeth. But these probably weren't living in the teeth. Earlier we were looking at some diatoms from sloth fur, or what we thought was diatoms from sloth fur. Maybe they're contamination. I'm not positive. But some sloth fur diatoms, and those were probably also not living on the sloths. They probably were just found there. So this is a really big chunk of a Stephanodiscus. And this is the diatom I really wanted to get a picture of. A clean image of this thing. But all I'm getting are little fragments. So I'm hoping that we can, sometime before we finish the stream, at least get one clean image of a Stephanodiscus. We keep getting these Lindavias, which is what I think this one is. And Oligocyra, which are these things. They're plankton. Like I said, they're found in lake systems. So living in deep water in lake systems, actually. So it's not just like they went swimming, probably, and picked these up. More likely they are from deep water. And we don't see a lot of anything else. So we did see some epithemia, but it was just one. That's a Lindavia again. Some sort of radiosa-like Lindavia. And that one's too small to be the stuff that we want. This is the primary issue with using a scanning electron microscope is that there's a lot of searching. There's a lot of like looking for things, and it's a challenge to find them in good shape and in good clean positions as well. That is the Lindavia that we've been looking for. It's an external view of it. You can see it's colliculate. It's got like a lumpy middle area with dots on it, and that's why I don't think this is likely to be something that people have seen before. I think that's probably a new species. That's a weird looking Lindavia to me, but it could just be one that I'm not familiar with, so don't get too excited, I guess. So the size for this one, there's roughly about 17 microns. It's probably closer to 16, but still super small. Our magnification is currently 16,000 times magnification, so that's the other thing not to worry about. These things are so small, you know, you're not going to be able to tell you had it in your teeth, so nothing to worry about. If you don't look, it's not there, right? Perfect. You're so getting a water pick. Maybe our ancestors made primitive water picks from bone and sheep platters. It could be. Sashimi, yeah. Have you tried to sample from my own teeth? No. I've never done that. That is a good question, Shimbucha. I have not thought to take a sample of diatoms from my teeth. I have sampled the pond behind my house, my koi pond, frequently. We look at those occasionally in the light microscope on my stream, and the birds in my backyard occasionally on my normal streams that aren't microscope streams. And sometimes we look at the moon, and sometimes I do woodworking, but like, I've never thought to sample my teeth for diatoms. I haven't tried that. Maybe I'll wait till just before I go to the dentist. I think my next dentist appointment's like 3 months out, and then I'll scrape a little bit out and see if I can find some diatoms in there. I'm more likely to have diatoms in my mouth than other people, though, because it's in my lab. So the dust has probably got a little bit of diatoms in it. Any animal without a dentist is likely to have diatoms. I mean, they're in the water, so if they eat things that live in the water, for sure. People have scraped turtle shells where diatoms are growing on the turtles, and there's definitely diatoms in the guts of fish and shrimp, and any type of zooplankton will have diatoms in its guts. Snails, for sure. You know, they're a thing that organisms eat. They, as I said, they're the base of a food web. They're in lakes and rivers, in the ocean. Diatoms are the main nutrients for small organisms and for middle-sized organisms. They're a little too small for things like whales to survive on. The whales usually eat the thing that's one step up from them, or sometimes 2 steps up from diatoms. But the rest of the organisms are all basically totally capable and likely to eat diatoms, either on purpose or an accident. So my intention for streaming is not to make people nervous about their teeth, by the way. Hopefully you're not bothered by what might be found in your teeth after you're dead, because that's what we're really talking about. but only if you look. If you're not looking, it's not really going to happen, right? So, all right, let's start our quest for Stephanodiscus and see if I can find one before it gets to be 5 o'clock Eastern time, and I feel like I need to go home. I feel like I got some good photos for our publication, regardless, and I don't know. The sloth ones I'm a little concerned about. I think maybe they might be contamination, and that they really didn't have much in them. Just because of the type of material that I was finding didn't look like something from a different sample that we had. So that is a Lindavia, and that is another Lindavia. I can tell because I see the little chambers around the outside edges, the alveolar chambers. And so the big circles there are Lindavia, and the little circles and rectangles everywhere here that look like little beer cans with spines coming off of them are Olichoceras. All of them. So that's Olichoceras, all of them. There were so many Stephanodiscus when I was looking at these things in the light microscopes, and it seems like it's so rare in these particular samples in the SEM. And that's troubling to me on some level, but let's get one more internal view of this guy before we give up on our Lindavia entirely. This is the same diatom we've been looking at, I think. You can see it's got the little dots in rows that radiate from the center. Its labiate processes here. The mantophotoportula and the costi here are on the edges. It's like there's one every costi. And if you look like slightly inside these, you can kind of see the little subcosti. I think, just starting to form in some of them. So I think that it's Lindavia SP, whatever the Lindavia is. I have no question, though, that I would be able to identify the Oligocera, the Lindavia, from the images that I have if we had them in the sediment samples as well. Both in the light microscope I could do it, and also in the SEM. So I think this is useful for us. I just need some pictures of the Stephanodiscus so I can try to see what it looks like in the SEM, and then if we get them in those lake sediment samples that are on their way, I'll be able to say that's definitely the same thing. So thank you for opening a door to this world. It's the world that I live in. The world of tiny little diatoms is my thing. Why would it be troubling me? What is this a sign of? Well, it could be a sign that we're just not looking at enough of the sample. Like if I had a little bit more of the sample, I might be able to find it. Or that something happened in the processing and then we lost some of them. But I think it's more likely we just haven't looked enough. Or there's a little bit of a bias mentally if you see something and then you think, oh, it's obvious I'm looking at that thing because it's a little bit bigger than the rest of the stuff. So I might have just been looking around and seeing the biggest things, and then and that's sort of biased my memory of what I saw. So these things are pretty. Some of the photos of insects and things on the lab Instagram were stuff of nightmare. Yes. Some of the close-ups of insects on the SEM are terrifying. The diatoms are filled with these really cool textures, like the ones that are showing up below me in the stream that goes by. Sometimes we just have like a close-up of this, like this one here, just like a close-up of the textures. Or if you use if you're a subscriber and you use the little emotes, you can see the textures in the heart things that are here. They have these really profoundly intricate little sets of holes in them that are characteristically diatom structures. You can just look at that and go, oh, that's a diatom. So, like, seeing those images below is a um, clear indication, basically, of what those textures look like. And I think that they're stunning. I mean, the images that we see from the SEM, I think, really are stunning. And I really like to sort of emphasize that. So, what do the beings that feed on diatoms look like? There's a really wide range of them. So, you know what snails and fish look like, right? Probably. So, like, those are some things that feed on them. But a lot of pretty much every one of the zooplankton, things that live in the water that eat phytoplankton, like algae, are um, terrifying in the SEM. So if you Googled, uh, I don't know, SEM and rotifer, for example, you'll see these terrifying things. They look horrendous as SEM images of things, but they're microscopic. So, um, and, if it was the size of a dog, you'd be terrified of it. You'd be scared of them probably, but in their normal size, they're invisible to humans, so they're not very scary to us naturally. Um, Ooh, what did we find? It's a little Fragillaria, I think. Just a piece of a diatom. There's another little piece of a diatom. That's another thing that could be happening. In the light microscope, things like clay aren't a problem because it's small enough you can see through it. And so you can see there's a bit of clay draped over top of these things. And so some of the diatoms that we were looking at might be draped in clay, and then I'm losing them a bit because they're covered. Because the SEM shows us topography. That is our same Lindavia. That is an external view, but this is one that has a innie. They have like innie and outie belly button shapes. This thing is curious. I don't know if that's a piece of clay. It looks like maybe it might be. That opening might be the rim of Portula. A little too close. Trying to find a middle ground. Like this. I slow the beam down so that the image quality improves. I'll do a little bit with the auto brightness and contrast so it's not so dark. And yes, OpenSet sometimes has both diatoms and rotifers on his stream. Mostly the Deloid rotifers because he's looking at moss samples or something like that. But he definitely has had them on his stream regularly. And he also sees diatoms quite a bit, but they're a little too small to really show up on his microscope. I mean, you can see them, but you can't see them very well. So that's the advantage of the SEM is, most of the stuff that he has on his microscope is maxing out at around 400 times magnification. He has like a 40x objective on there with a 10x magnification on top of it. So you're looking at things that are basically magnified 400 times or less for most of his streams. And then I don't think he ever really uses the 100x objective on his streams. But if you're interested in microscope streams, I have a huge list of people who are microscope streamers on Twitch. And some of those people haven't streamed in a little while, and there's some new ones that are sort of coming on board. I know that Science has got their microscope up and running. I don't know that they've got it hooked up to do a Twitch stream from it quite yet, but they're working on it. And also Volcano Doc she's got a mineral microscope, a petrographic microscope that she's working on connecting up to Twitch as well. So if you're really interested in sort of microscopic stuff, that's a great list of people. OpenSet plays music, and sometimes he just cooks burgers and stuff, but a lot of times he streams late at night. Pacific Plankton is up there at the top of the list. She hasn't streamed for a little bit. She's sort of been on a break, but she looks at live stuff in the light microscope. I sometimes look at live stuff in the microscope when I'm not looking at stuff in the SEM. Spider ID usually on in the afternoons. It looks at stuff with a stereo microscope. Freckled Science occasionally puts stuff on a light microscope. Things like water bears. I look at water bears sometimes too. Porcelain Giant, I think they've been mostly doing graphics stuff or something recently, but they also did some microscope streams, as did Line Wizard. Protozoan Princess is an artist who also uses microscopes in her work. I haven't seen her in a while, but she's on really late at night. Jolkson is probably the person who's been streaming the most recently from the microscope, from the light microscope. I see him on, every other day, looking at stuff. He usually just lets he doesn't do a lot of talking. He doesn't have a camera, but just basically shows you what's on his screen and talks a little bit about it sometimes, but usually not. I haven't seen Nidstream or Pengaline recently, but that's a pretty big list. Fazaria's on there. She usually does singing, keyboard, guitar, sometimes some art, but she also has a microscope she sometimes pulls out. So, and she looks at water samples. So, they're all really great people. If you're interested in microscope streaming, I highly recommend all of them. So, I think I'm the only one with a scanning electron microscope, but I don't always stream from the scanning. Sometimes I use my stereoscopes and light microscopes to look at stuff as well. So I have the advantage in that I'm a scientist with a full lab of microscopes and ability to do research right on Twitch. So a little different than most of those guys in that I'm a professor. And I have a lot more toys as a result. So, but I still think you could learn a lot from watching all of them. And when they're on and I'm on, I usually try to catch them. So, Freckled's on every night, so you can't miss her. She's got a lot of funny content, but sometimes microscope stuff. Great to check out, and great communities all of them have, full of cool, friendly people. So that is the inside view of that Cyclotella again. I really want a nice view of our Stephanodiscus. Tired of only finding Lindavias. Same thing every time. Let's go sample. Maybe this one. Maybe. I think that's a Lindavia. It's a little dissolved. You can see the edges of it are kind of ripped out, but you can actually see the whole valve face in this one without it being covered with mud. You can see all of the areolae, so I will get a picture of it. Almost 5 o'clock. Stephanodiscus, goat farmer, is Stephanodiscus. Like this. And they get their name from, something took a bite out of this one, exactly. They get their name from, hey, Devil and Mrs. J. Stefano means crown in Latin, and discus, so they are the crown disc. That's what we're looking for. No, no. Fazaria is mostly a musician. She does occasionally. She just does some other things, and one of those things is pull out a microscope. But she's mostly a musician. She hasn't transitioned. When I first met her, she was only doing music streams, and then, like, occasionally she would do some art streams. Um, but she used to hang out in Pacific Plankton Stream quite a bit, and then she decided she wanted to get a microscope and try to do some microscope streaming. And she probably only pulls it out like every other month, but um, but she definitely still pulls her microscope out and looks at stuff occasionally. Sometimes it's just food or whatnot, but it's good. So. Um, Like all men, I never grew up. My toys just become more expensive. Is that just men? I feel like there's a lot of people whose toys just become more expensive. It's not just men, but I will accept a Peter Pan-esque compliment, I guess. Crashed a tab opening the whole list at once. Um, yeah, so Devil and Mrs. J is here. That's MRSJ. There you go. She does some cool streams, gaming streaming, and some crafting streaming. I haven't seen you do any crafting streaming for a while, Mrs. J. But sort of pixel art streams for a long time there at the beginning. So something definitely took a bite out of this. I think more likely this cookie just got broken, but if it feels better to say it got bitten, sure. You can see that it's kind of a thick piece of silica on the valve face here. Kind of neat. Okay, this is exterior view. I'm just going to stick a 2 on there. See if we can find a Stephanodiscus somehow. Maybe if I increase the beam intensity, it will help if I zoom out a bit. We can see a bit more of the field of view this way, but everything is slightly lower magnification, and so it's a little bit harder to tell what I'm looking at. But you see this is a fragment of a Stephanodiscus. Positive of that. Here's the a piece of one. They're bigger, generally bigger than the Lindavia. Maybe 50 microns is a reasonable size guess for them. I haven't seen a whole lot of like whole versions of them. Maybe here? Yes. Yes, yes. It's this thing. I wish we had an external view. There's a nice internal view, though. See, it had little spines sticking out the top over here. Hopefully we can get another one, but this is enough probably to help put a name on it, or at least when I see it again I'll know. So this one's about 50 microns, just about the right size. Does the software have a pattern recognition? Oh, that's cool, conceded. Cutting fabric at work, okay. She does pixel art doing like, what are those little bead things called? I can't remember what they are. They're like little beads that you put in a thing. And then you iron them. Perler beads, yeah, that's what it is. Sorry, Sylvie does them sometimes, but she does her own like pixel perler art and then turns them into objects, hair clips and brooches and whatever else, right? My toys became more expensive as well. I may be 73, but I will never grow up. uh, Growing up is overrated, so don't do it. Um, does the software have a pattern recognition? No. The software that we're using is just basically an interface, so I can control the SEM that's next to us. And um, the best it can do is, by itself, is let me control the focus. And I'm doing all that, changing the speed so that I can move around, and then changing the beam intensity so that the resolution improves, and slowing the speed down so the resolution improves. It can do pretty good brightness and contrast detection, but you can um, you can get software that can be modified, that can modify this thing and help control it. It's just that that's super expensive, and it's a lot easier for a human being to do something like this, to get the images in focus and to get the select the things that they want to get. They do have a. I asked them about it. They said, "Oh, you can get this sort of thing that will move the SEM in increments and take a picture at each increment. So if you wanted to scan the whole thing and build a giant, like monster-size image, and then you could use pattern recognition software on that monster-size image pretty easily. But again, it would take up a lot of time on the machine, and I don't know that it would be better in terms of resources than just having somebody who knows what they're doing, because the pictures wouldn't be as good. Um, it's challenging for a machine to figure out what thing it should be focused on when it's trying to look at an organism. So my camera doesn't have a very good sense of like what it's supposed to be focused on when I'm taking pictures. So as an example, and those cameras can be pretty smart. They can figure out, like, they have ones that will detect birds, and but it still doesn't know where on the bird I want focused, right? So that's an issue. Um, but you're right, a lot of the work associated with the scanning electron microscope is the hunting part, and it would be great if there was some software that would do the hunting for us. I wouldn't complain. I think it's just the problem is there's not enough resources for people. Like, there's, let's say, in all of the world, maybe 1,000 people that know diatoms well enough to identify them. And there's not like an industrial or a business purpose for a lot of identification of diatoms. There is in the oil industry a little bit, but the oil industry is mostly dying. And I don't know that it would be valuable for somebody to like program what I think you're leading towards, which is like a model of that we could use for having it do all the work for me, which people ask me regularly. Like, is there a way, rather than me doing it, that a machine just does it? I think it's probably in our capacity to do that. I just don't think that anybody's all that interested in programming it, because it might take a ridiculously large amount of time to program something like that. You'd need the expertise of a diatomist to do it, and then every time you went someplace new and the diatoms were something the machine wouldn't be able to recognize, it'd have to get programmed for those organisms you're looking for. So I just feel like it's easier to program a human. We're pretty easy to program, and some aspects of it might be valuable to try to have a machine do, but I feel like maybe that one's not so much. Ooh, that's a pretty one. That is the Stephanodiscus. It's nice and clean. It's broken, but it's at least clean. The field of view is 40 microns-ish. So roughly the same as that other really big one. And that is the regular that we've seen so far for this thing, is that it's rather large. Radiant. Diatom, this is Stephanodiscus. Or maybe something, not Stephanodiscus, but close to it, possibly. New CAPTCHA content. I guess so. You could do it that way. I can buy followers? Oh man, that is great to know. I feel like I have enough followers, dude. Harder to deprogram, probably. Probably a little bit harder to deprogram them, yeah. You could help out if I want original, professional-looking sprites to turn into wall art. Sprites. I'm not sure I know what you mean, but, you know, if you want to chat about something with me, about, like, collaboration, hop onto the Discord. And we can chat about it. That'll be cool. I'd love to collaborate. I can give you some material, or vice versa. You know, I have most of the images I just dump onto Instagram and to Twitter and give away for free for diatom stuff. I feel like it's part of just part of my job, even though I'm doing my own artwork over top of it. I'd rather get people interested in science and share it for free, I think. Sprites are pixel art that is animated inside a game. Do you think there is potential for pixel art and diatom crossover? Maybe. There is the association of tiny stuff in common. Yeah. Maybe. I know somebody at some point told me that the diatoms are like collecting Pokemon and that we should make a Pokemon game where you'd basically have diatom Pokemon. I don't know that they would work as 8-bit art, but maybe the next block up, I don't know. It might be interesting. I don't know. We could chat about it. Like I said, my job is really, I'm a full-time professor, and this is just something I do mostly for fun. So, not the diatom part, the sharing it with people on Twitch part. Diatom stuff I do for my job, my research. So. If I had money to spend on anything, like I won the lottery, I probably would just have an SEM in my house. That would be like a good purchase for my toys at home. For two reasons. My wife also studies diatoms and also has a PhD, and she probably would spend most of her time on it if I did that. So if you're thinking your wife wouldn't possibly let you do that, she would. She does. She'd probably be completely happy with that decision. Here's another little Stephanodiscus. This is a different one. This might be Cyclostephanos even. That's something totally different as a diatom than what we've been looking at. It's in the same family, Stephanodisciaceae, but a different species for sure. You can see it's got like a huge indented interfascicle space, and the costae are thick, and a rounded dome for the central part, and then it looks like maybe the costae don't quite go all the way to the outside margin, but they get close. What the heck, Encephalosaurus? We got it rated by Encephalosaurus. Hello. Uh, Welcome in. How was your stream? What's going on? If you're not following Jess, you should. Uh, nope, yep. Um, what were you streaming about today? Um, Welcome in, streamers. We're looking at some stuff in the scanning electron microscope. Back propagation. Back propagation? What is back propagation? Is it something to do with your back? Or is it like propagating things backwards? I think I know what the word propagation means, and I know what the word back means. Just not sure what you mean when you use them together. Is it a programming thing? Calculus. Okay. How's it going, Jess? It's great to see you here. I'm actually getting towards the end of my stream, but that's okay. We're working on collecting some diatom images on the scanning electron microscope. So this is the samples that we're looking at on little tiny stubs. They're this sized. So that's inside the chamber over there. This one, inside the chamber. And this one over here is the current image that we're collecting. These samples were collected from teeth of people. This little calculus. You're talking about calculus. I'm going to talk a little bit about calculus. The dental calculus, the hardened bit of teeth goo between your teeth. From skeletons that are thousands of years old. They scraped this stuff and then processed it, and they sent it to me, and they said, we found a bunch of diatoms in this stuff, and is there any way you could tell us what they are? And I said, oh yeah. Why would they eat diatoms? This is a great question. They want to know why these diatoms are found in their teeth. And I said, well, first, let me tell you what these diatoms are. This is Stephanodiscus. That one is, Lindavia. This one over here is Allocasyra. And those are plankton. And they're usually found in lake systems. And they said, well, like on the shores. And I said, no, those are deep water diatoms, all of them. We did find some epithemia, which are shallow water diatoms, but these are deep water diatoms. And they're found in lake systems. And they said, well, these things, why would people have these stuck in their teeth? And I said, well, maybe they were eating something out of the lake. Maybe they were potentially buried in lake sediments. I don't know. I didn't collect them. And they got very excited. And they asked me to take a look at the teeth samples in the SEM, which I have. And no, we can't see atoms. That's too small for the. Did we get 2 raids? Did that happen? I only see 1. Is there 2? Did you get raided on the backside of Jess's raid? Maybe. Yeah. So raid right as you go to raid someone else. Yeah, that's fine. So they collected this stuff and they sent it to me, and I've been trying to figure out what the diatoms are. They're going to send me some samples from the lake that was adjacent to the people. And they've taken a core that goes back in time, and they've dated the intervals where the people were alive on the landscape. And they wanted me to look at the lake samples and tell them, are these the same organisms that were living in the lake when the people were living there and had stuff in their teeth? Sometimes this is my job. It's a pretty cool one, which is basically looking at ancient diatoms. And sometimes I'm working with anthropologists looking at stuff that got stuck in ancient people's teeth. So there you go. We can't zoom into the point where we see atoms, so sorry about that. That's not quite the range of sizes. We can get down to about 200,000 times magnification, but 200,000 times is not nearly close enough to see atoms. So I was just trying to find one or two more views of this Stephanodiscus. This is a Stephanodiscus, or Cyclostephanos, actually. I'm not sure which. It looks like maybe there's some connection all the way to the edge, so I thought maybe this was a Cyclostephanos. But it's the first one I've seen. And then I was trying to find some of these, the larger ones are Stephanodiscus, and I was trying to find, they're like 50 microns in size. So when I say large, take it with the idea that large for me is pretty small still. But I wanted to get a nice external view of one of these Stephanodiscus species in here, so that if I see them again in the lake sediment samples, I can tell for sure that that's what I'm looking at. And these samples are from, I think, Africa or Levant province, something like that. I'm not totally positive, because I've just got helicoptered in on the project, since sometimes those are Cyclatellas or Lindavias. There's a little piece of a Stephanodiscus. So yeah, I don't know exactly where they were collected, but sometimes that's not helpful information for me anyways. I'm really just trying to compare what we see in this sample with another sample when they send it to me eventually. So the scanning electron microscope is really an interesting tool, because you don't have the normal objectives. Like a normal microscope has objectives that stop you at specific distances from the subject. And in a scanning electron microscope, you zoom in till you just can't get it in focus anymore. So there's no limit until you just can't get a clean picture. You can keep zooming in. So I'll try to give you a sense of what I mean by that. If I zoom all the way out, like this, right, you can see the whole field of view is 2 millimeters. Most people know what a millimeter is. So the smallest tick on the metric side of the rulers that you used in grade school or whatever, 2 of those are the smallest ticks, right? That's our whole field of view. That's everything we're seeing here, is that 2 millimeters. And if I just pick something out of this mess, like this is the Stephanodiscus we were imaging earlier, and there's an Olicocyra right next to it. I know that because when I took the picture I was paying attention. And if you just watch what happens when I zoom in, you'll see the scale bar at the bottom jumping as it goes. As we get closer, you see this is 200 microns. In the field of view, this is now 1 millimeter. And the magnification currently that we're at right now is 290 times. So a typical light microscope that you might see on OpenSet Stream or Pacific Plankton Stream stops at this sort of a magnification. So if they showed you diatoms and you had a large diatom, it would look like one of these, like this size. And if you were to put it on a really nice high-grade light microscope with a oil immersion lens, you'd get a 1,000 times magnification, which looks something like this. So on a nice light microscope, your image would basically look like this in terms of how much you could see, right? So the diatoms are big, but they're not monstrous. And you could see they have some details, but you can't see very well what those details are. In the scanning electron microscope, we don't have to stop there. We can just keep going. And that's because it doesn't use light to see, it uses electrons. And now we're zoomed in so that our entire field of view just one diatom. That's actually two valves of sibling sister diatoms. And then you can start to see the detail, all the detail of the actual diatoms this way. And we're right now, this is at 10,000 times magnification. And a typical light microscope has a maximum magnification of around 1,000. And even if you get one that has special objectives that goes up to 2,000, it doesn't really get any better than this. It actually makes it kind of worse because it's like taking the picture and projecting it on a side of a building. You could make it as big as you want, but it doesn't actually get you more detail. It just makes it bigger. So when you get anything past around 600 times magnification on a light microscope, it's actually degrading the quality. It's just making it bigger. You're not actually seeing things in high resolution or higher resolution by making it bigger. Whereas here, we're seeing them at the native resolution at 10,000 times. But that's not actually the limit. It's not anywhere near the limit for our instrument. So if we just want to zoom in on one of these spines and just look at the spine, for example, now you'll see the scale at the bottom says 1 micron. So there's 1,000 microns in a millimeter. So we are 4 microns for the whole field of view. And currently this is 66,000 times magnification. And, you know, if I tweak the image a little bit, we basically could see totally clearly at 70, 80, 90, 100,000. In fact, we can get up to 200,000 without completely losing our ability to see what we're looking at. So it's a huge advantage when you can zoom in this closely on things, and then you can see them in a lot more detail without losing resolution in the process. So pretty cool. This is a scanning electron microscope lab. It's my lab. I'm a professor, and I have 2 labs, this one and I have a light microscope lab. So this is the one that I sit around in and try to identify diatoms on the scanning electron microscope. Sometimes it's used by other people, but it's mostly my lab. And I'm a professor. That's what I do for my job, is look at diatoms. Sometimes I look at them to try to figure out what got stuck in the teeth of dead people. Kind of cool. It's kind of a cool job. Yeah, so that's a little background of the SEM. Maybe next time we do a stream, I'll actually pop out the little phone camera, and then we can take a tour of the lab. But for today, I think we have to start getting close to stopping. I was been streaming for a while, and my dinner's going to be cooked soon, so I need to start thinking about going home. So I think we got everything that we need for now. I've got some nice clean images for publication that will work just fine, and I have some new samples that will be coming that will help us sort of take a look at these when we get the lake sediments, so I can compare them with them capably. Sorry, that was a lot of talking and not a lot of looking to see what's going on in the chat. I'm quite cool. Thank you, Loafbone. You're quite cool. Yeah. Sorry, I'll scroll back and see what's going on. Sorry. How big is the SEM? It's about the size of 2 computer towers stacked on top of each other on this desk. But mine is actually built into the desk. So, here, I can show you. I can just turn the camera. There's the actual SEM that's next to me. So it's like the size of another computer, like 2 towers stacked on top of each other. That's the column. And there's a whole bunch of circuitry inside this panel here that's the side of the desk that we use. And then I also have 2 computers plugged into the back of the SEM that I can control it with. So, let's see. Did you say they have taken a core that goes back in time? Yes, they've taken sediment cores that are right next to the sites where we are, where these were collected, where the people lived at the time. Diatoms are really awesome. Thank you, Jess. Is that if there's ever an opportunity to do some ML and diatoms collab awesomeness, okay, I'll let you know. Is ML MATLAB? Is that what ML is? Because there's plenty of opportunity to do MATLAB diatom collaboration. I don't know what ML stands for. Yeah, you're understanding it. I think conceded. A sediment core, yeah. Yeah, just the best images of atoms are mostly fuzzy balls. Yes, I agree. So something that is preserved, got you, sounded like sci-fi jargon. No, it's real. A sediment core. It's like the lake, stuff in the lake dies and then gets buried over time. Americans don't know what a millimeter is? Sure they do. It's the side that they don't use on the ruler. That side. Yeah, our rulers have millimeters on them. They just don't think in millimeters typically. You love, oh, disk of accretion, yes. Let's see. I feel like I'm almost caught up. Yes, we can get to nanometers on my microscope. So the scale bar will jump over to nanometers after some point. So we can definitely get down to nanometers. I think most of the images that we can collect, the best quality image I've gotten, the scale bar is sort of at 200 nanometers. So if something is like 200 nanometers or bigger, we probably could get it and it would be okay. It would be a little fuzzy. But I usually take my images out of here because SEM images are pretty noisy and I filter them through Topaz Labs. So I probably could take a picture with the 200 nanometer scale bar on the screen and still be able to turn it into something that looks okay. Just would require heavy modification. So, can I put a CPU in it? Yes, you definitely can. I don't have any CPUs to stick in there, but you can. Software that cleans up the picture, or why is the picture noisy? It's just inherently noisy because what happens is the image is created by the SEM scanning across the surface, and at each point it's hitting the subject with electrons, and the electrons are going into the surface of whatever is on the stage and knocking electrons out of the molecular structure of the things that it's hitting. And so it has a positively charged receptor that sort of vacuums up those electrons immediately after they leave the sample. And the more that hit the receptor, the brighter the image gets. And the less that hit, the darker the image is. So if something's sort of pointed away from the SEM and bounces out that way, and the receptor's over here, it appears dark. So what it produces is basically a topographic image. And while that's super cool because we're using electrons, but we're producing microscopic topography, the number of electrons that are coming is not like a photograph where the resolution is like based on wavelengths. It's based on the number of pixels that are captured at each point where it's going. And so when I'm using the SEM, for example, and I change the speed, see now it kind of looks like partly grainy, and now it looks very grainy. I just changed the speed at which the beam is scanning. And I can slow it down, and I can keep slowing it down and keep slowing it down. And each time I do, the noise decreases. But the length of time it takes to scan across the image increases, and they're proportional. So when I take a picture, and I want to take a picture that only requires me to have somewhere between 5 and 10 minutes at most, the longer I take, the less noise associated with the image. But the image quality that we have it set on right now, which is speed 10, takes an hour and a half to scan across the whole image. and I don't want to wait an hour and a half. So what I usually do is sacrifice a little bit of the image quality for speed, and I set it to 7. That's this speed. And then I can get a picture, and it only takes 3 minutes, but there's a little bit of noise associated with it. And so that's just a sacrifice that I make because I don't want to wait an hour and a half for a photo. So it's always a little bit of noise associated with it as a result. So hopefully that's a clear explanation. Machine learning. Oh, sorry, machine learning. Got it. You wish your dinner would cook without your involvement. Well, you could just come over and move into my house, and then your dinner would be my dinner, and it would cook without your involvement on that level. I think that would create some additional problems for you. So, yeah, machine learning. Sorry, I figured it's something I didn't know. We could try some machine learning stuff, but I have a grad student who was doing some machine learning and trying to use it for diatom stuff. He mostly did like remote sensing things with it, but he wanted to try diatom stuff. And I gave him some files, but then I don't know what he did with it. So, and he graduated, so I haven't been pushing him about it. He's been working on other stuff, trying to get a job somewhere. So, okay, yeah. Noise reduction sounds like a machine learning application. They do use the noise reduction tools. The Topaz Lab uses an AI with some sort of, I don't know if it's machine learning that's in Topaz Labs, but it's some sort of wizardry that will take things and denoise them. And it's really pretty interesting, but doesn't require us to program like anything. It just figures out what shape should be. Like it looks like it should be a circle, it'll make it a circle. So noises, yeah, it doesn't really bother, but I think it uses sorcery, exactly. It's just sort of a magic tool. So anyway, like I said, we were getting to the point where I need to go eat my food, my meals for dinner. And I've been, I don't know, streaming for 3 hours or something. Is this 3 hours yet? And my throat is sore because I gave lectures yesterday for the first time. Our classes started yesterday. I had to talk for like 2 hours straight, and then I just talked for 3 hours straight. So my throat's out of practice. I haven't reached the mid-season form. So, yeah. Yeah. So anyway, that's where we are. And I want to say thanks to Jess again for the raid, for bringing your people in to visit my scanning electron microscope lab. And probably I'm going to hop off now. I'm going to go raid somebody else before I get sneak attacked by somebody else. We had a bunch of follows. I'm sorry, I'm trying to figure out who I want to raid here. I'm going to read them to us in a second, so just one moment. Gotta learn to type and think at the same time. We'll go raid Numb the Geek, who's one of my favorite music streamers. And next time probably I'll be talking some more about diatoms picked out of teeth, but that's not what we do here usually. So it is what we've done recently, just today. And we also looked at some diatoms that came from sloths, but I'm a little concerned about whether they were contaminated. So we had follows from Ear Entier, Wabu the Panda, Cellar Door, Jedi Mega Man, Merlin the Mew, and Paketia 12. These people came in with Jess's raid. And then before that, we got followed by Yanis Chembucha, which had some great conversation with us here. Detector Mankey, who asked me about mites. Corkboard gave a sub out to Chippy Flip. Octims, who's been in the stream for most of the last 2 hours, followed along. Corkboard also resubscribed. Follows from Oaf June as well. So a pretty good day for streaming. Thank you guys for all the follows. And now we're going to go listen to, if you stick around, we're going to go right in with Numb the Geek, who's one of my favorite music streamers. So hopefully you will, and you'll enjoy him. He does violin stuff and other things. So we'll catch you next time.